66. My pen's like drying out. I think I ran out of ink officially. Okay, so that's 66. We are talking about perpendicular bisectors and angle bisectors. Does anybody remember what a bisector means? In the middle. It like cuts it down the half. Whatever you're talking about, it's cutting in half into two congruent parts. What about perpendicular? It has opposite reciprocals. But like, what else does perpendicular mean? 90 degrees. So anytime you see perpendicular, you're talking about 90 degrees. Bisectors are talking about like two equal or two congruent parts, whatever, whether it be an angle or like a piece of a segment or like a line, you're cutting it in half basically. Okay, so you could read this paragraph if you want. I'm not going to, so I'm just going to explain it because like words. Okay, so the perpendicular bisector theorem, this is specifically for triangles, is if you have a perpendicular bisector, you have this 90-degree angle, you know that these two pieces are congruent. So this is what this says. It says if CD is upside down capital T, where's CD? CD is upside down capital T, D to AB. That upside down capital T means 90 degrees. It's making a right angle. And AD is congruent to DB. This information has to be given to you. Once you know these two things, or these two things are already in your picture, then you can automatically add something else to your picture. You could put a little tick mark here, a little tick, tick. What would AC be congruent to on the other triangle? CB or BC, either way you write it, as long as it's B and C, that is technically correct. So I'm going to add 2 marks there because those are different lengths in the bottom. Okay. The converse of that, so it's literally just means the opposite of this. If I am given that these two parts are congruent, then I can automatically go in and add the pieces of information from before. I can add in that these two are equal. And I can also add in my right angle. So it's kind of like, if I know that, then I could just use the same thing backwards, just going backwards to use the same like knowledge. So if I know that those are congruent, I could say AD is congruent to BD. And then I could also know that CD is perpendicular, so upside down capital T, to AB, meaning that those two lines make that right angle because they would like cross paths. Okay, so using this kind of like knowledge and this idea, let's take a second and look at number 1. What do you think I'm going to have to do for this kind of problem? Yeah, because if those are given to each other and those are equal, then automatically I can add in that these are equal to each other, because that's the whole point of the perpendicular bisector theorem. And it's kind of like using common sense, like, oh, that would make sense because they look the same. And in geometry, it's usually like the picture's not trying to trick you unless it's like says specifically it's not drawn to scale. So we're going to set them equal to each other. So what do you want to move to the other side? Ooh, okay. Minus 7x, minus 7x. Wait, that's what I was thinking, but that's okay. I mean, there's 4 ways to solve an equation. It doesn't matter. So 13x minus 7x is what? 6. Nice. And then what would I have to do? Add 48. Add 48. So 24 plus 48. 72. And then if you divide by 6, what do you get? Did you hear that? Oh, okay. How do we feel? Okay. Let's try another one. Let's try number 3. Take a second. Try number 3. Easy peasy. Lemon squeezy. Nobody not. Are you checking something?
I was wrong.
Oh my God. Okay, thank you. You guys, nobody even caught it. I was like waiting for someone to get extra credit. I like was like pausing. Well, you said, yeah, I'll give you extra credit because you fixed yourself. I like even gave everybody a moment and I was like, okay, well, I guess we're just gonna write 6 or 9 or whatever we wrote. Okay. If I make a mistake, sometimes I'll just leave them there to see if like you notice. Maybe you should use a calculator. Okay. Yeah. Okay. So set them equal to each other. So what do we end up getting for this one? Okay, x equals 9 this time. But that's not technically the answer. What do you have to do for this problem? You have to plug it back in. So if it says find RS, a lot of people are still really uncomfortable with plugging back in answers. You will there, like 99% of the EOC is going to have you take X and plug it back in. So you need to like work on that. So it says find RS. RS is this section. So you're plugging it back in. You can just do this in the calculator. You don't have to write it out. You're doing 4 multiplied by 9 and you're adding 5. I'm going to write it down, but you don't have to. 4 times 9 plus 5. So what do you get? 41. So the actual answer is 41. Easy peasy. Okay, let's move on to the next side. So the next side is angle bisectors. So angle bisectors are kind of like the same thing. These are perpendicular bisectors of a triangle. So it's like cutting the segments in half and cutting pieces in half. This is an angle bisector. Same idea, but now we're talking about the angles. So an angle bisector we did during chapter 2, and it's taking something and it's just splitting into 2 equal parts. So the idea behind this, that if AD bisects, so AD bisects angle BAC, because you have 3 letters, BAC, this is cutting it in half. Those arcs are telling you they're congruent. So if I know that this one's like 30, then that one would automatically have to be 30 because they're 2 equal pieces. And I have to know that AB is perpendicular to BD, which they have that symbol there. That's the right angle. And AC is perpendicular to CD, which this is the right angle. Then I can add one piece of information to this. I can add one piece of information to my picture, which is that BD is congruent to what section? CD. And then same thing, the converse is just going backwards. So if I know that these pieces are congruent and I know that those are perpendicular, then I can add in that the angles are congruent. So I can just add in my little angle markers. And then that basically tells me that angle, if I say DAB, what would have to be the order for the second angle? Not A. Nope. DAC. So if this is splitting it in half, then these 2 angles, if I start at D, I go to A and I end at B, then I'm starting at D, going to A, ending at C. Those 2 angles are congruent, whatever their measures are. Okay, so using this idea, easy peasy lemon squeezy, let's do number 5. So looking at number 5's picture, what could I do for number 5? They both do have 90-degree angles in the corner, but those 90-degree angles don't have to really do with these angles right here. Equal them to each other. So this is very easy. It's not terrible. You're finding equal pieces. So I'm going to set these equal to each other. And then you have to try to figure out, once you find your X, where does this actually get plugged back into? Because the answer is technically not X. Yeah, it's like the same thing, but now we're angles, which is like fine because it's the same thing. Then the back, you're going to be like, what? But it's the same thing. So what do you get for x? 19. Okay, good. But that's not the answer. It says that you need to find the measure. That's what the M means. People are like, there's no M in the picture. That's because it means measure. The measure of the angle, it looks like a little inequality. That means angle of F, G, and I'm ending at H. So I'm talking about this whole green section on my picture. So what do you got to do? Beautiful. So you could plug it in to each of them. Boop, 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 boop. Okay. And then you're going to add them together. What else could you technically do? What? Okay, hold on, wait. Let's just plug it in. So 2x plus 20 in the calculator. If you do 2 times 19 plus 20, what do you get? 58. So then, does anybody know what the other angle would have to automatically be without doing any math? 58, because the whole point of it is it's an angle bisector. So you could plug it in here and plug it in here and both get 58. Or you just multiply by 2 because you need the whole angle. So what's the final answer? 116. Okay, so now let's go to the back and blow your mind. Just because the pictures are ugly does not mean it's hard. There's back. Surprise. So let's go to the back. 168. That's not right. 116. Thanks for calling me out, people. Okay. So on the back, let's go to number 2. So using this idea, we're going to figure out number 2. It looks bad. It's very easy. It's not terrible. Okay, so it says XY is perpendicular bisector of RS and TU. So it's perpendicular bisector. I need to find X to S. Mm-hmm. Yeah, because if this is 12, then this is 12. It's matching pieces, just like we did on the front. If that side's this, then it's equal to that. And so you could technically equal them to each other. This is not an equation, though. You're just finding the matching numbers. So take a second. It's not bad. I promise you. Try to fill in all the rest of them. It's like a little puzzle. You guys got this. This is easy peasy. Lemon squeezy. And putting the numbers on the picture might help you, like in the long run.
This doesn't look like what we did yesterday.
It's not the same as yesterday. That's why it's new. It's the same as the front, which is just finding equal parts. But tomorrow we're gonna mash this and the Pythagorean theorem like together. And it's gonna have like a little baby. And it's gonna be new problems. Genius. Beautiful. Go to the next one. Easy peasy. Lemon squeezy. It's not hard. You just gotta think a little. Yeah, it's not bad. It's not bad. Are we ready to talk about the answers? You think you got it? Easy peasy.
So for number 4, we have to what?
Do math? Yeah. Okay, XT. What is XT? 16. Okay, you're a genius, genius. Okay, TU. 14, because this one's 7, so that one's 7, so the whole thing's 14 because you got to add them together. What about ZS? 4 and TR? Where's TR? I don't even know. Oh, TR is right here. How do we find TR? So if this whole thing is 16, bloop, bloop, because it matches the other side, and this piece is 12 and the whole thing's 16, all you're doing is subtracting them. So you get 4 because they have to add to make 16. So 4. Okay, so the problems might be really ugly, but that's not that bad. Okay. Let's go to number 4, because number 4 is another one that's like, That's not cute. So let's go to number 4. Number 4 has a lot going on and the picture is really like blurry, but it's okay. We'll work with it. Okay. So we have this nonsense. And I think this is kind of like a lot to look at right away. So like, let's just look at the picture. You have X's and you have Y's, and then you have things with X's and Y's. When you have multiple variables in a problem, what should you do? Well, yeah, you got to solve them, but like, where's a good starting place if you have multiple variables in a problem? Hmm? Okay, so we're going to talk about like terms. So you can't combine X's and Y's together. So just start with like just looking at the X's to start. So this just has Y, so let's not look at that. This just has Y, so let's not look at that. This has X's and Y, so we can't really do anything with that because we don't know Y yet. So what could I do with the pieces that are left? Equal them to each other. So I can't combine them to each other because I'm not adding to make 180 because it's not like the inside of a triangle. But these pieces, based on what we just learned, perpendicular bisectors, these are going to be congruent because it's like the top of a kite. So I can set the X and the X equal to each other. So take a second, solve for X. Nice. Try to find Y. So once you find X, try to find Y. Y has technically 3 equations. 2 of them are going to be equal to each other. So you're not using all 3 to find the Y. You got to look at your picture and figure out which 2 pieces would actually equal to each other. Nope. Start plugging things back in. So what we get for X? Nice. Okay, so you should get X equals 6. Now, if you're looking at all your Y's, you have this, you got this, you got this. Which 2 are actually going to be equal to each other? 12y minus 8, and then 8y plus 20. Because it's like the bottom of the kite. Those pieces are congruent to each other. So it's like a triangle this way. So those are going to be congruent, so I can equal those to each other. So if you haven't already done so, solve for y. If you're already done solving for y, then you can start plugging things back in because you're going to basically need to find all of these missing pieces by substituting your answer back in. So what do we get for y? 7. And then if you start plugging things back in, if you do 8x plus 6 in a calculator, you're doing 8 times 6 and you're adding 6. So what do you end up for this section right here? 50, what is it, 54? 54. Where else can 54 automatically go? BC, because they match. Or you could have plugged it in there too, but they match, so you're going to end up with 54 no matter what. What about the orange parts? What is this? 76. And then 76 can go in the other orange part. So over here, so this will be 76. And then the last part that we haven't talked about yet is technically this section, which is AE. AE is combining 2x and 4y. So if I do 2 times 6 and 4 times 7 and I add them together, you get 40. Yeah. Okay. So So now we're going to actually fill in our answers. So we have AEB. What's that going to be? 54. What about AE? 40. What about AD? 76. What about BC? 54. And then AC? 80. This one's going to be 80 because if this is 40, then this is also going to be 40 because they match. So 40 and 40 added together, or 40 times 2 is 80. And then CD, 76. So that's not terrible, right? It's like manageable. We're having so much fun. It's such a great time. Okay, let's set up one more and then you guys can finish the rest. So down here for number 5, I'll leave this up here for a second. Down here for number 5, it tells you that it's a perpendicular bisector of BC, but there's nothing in your picture. If you know it's a perpendicular bisector, you know that the bottoms are congruent. You know that the sides are the same. And you also know something else. What else do you know if it's a perpendicular bisector? It's a right angle. So I'm going to put that in my picture because this stuff is going to help me once I put the numbers in the problem. So it tells me that the measure of angle, because people freak out and they're like, there's no M. Ah! Okay, so it's the measure of angle ADB. So we're talking about inside the triangle. So A to D to B is 7x plus 27. Okay, I have to find x. So what do? You equal it to 90 because it's a right angle. So these two are in the same spot. So you're doing 7x plus 27 equals 90. That's easy peasy. It's a 2-step equation. And then, so take a second because most of you are probably solving that right now in your calculator. And then we'll do B together. This one you don't have to plug back in because it just says find x. You don't have to plug it back in to find the angle total because then it would just be 90. What do you end up getting for this? 9. Good. Okay, so B says BC, which is the length. It's not an angle. BC going that distance is 3y minus 7. So this whole thing, nope, because 180 is the inside of a triangle. So it says BD is y plus 3. So BD right here is y plus 3. So what could I do? What? Nope, because 90 is the inside of a triangle. We're talking about side lengths, so it's literally all the outsides. So the outside of this piece is y plus 3. The outside of the whole thing is 3y minus 7. So we're not using 180. We're not using 90. Do they equal to each other? Does this piece equal to this? No, because this is bigger. Yes. So you can either put y plus 3 also here and then combine those pieces because they're congruent and equal it to the whole thing. Or what she just said was basically you could just multiply the one side by 2 and equal it to the whole length because they're the same. So I could just multiply by 2. And then the parentheses, somebody during first period like forgot what the distributive property was. You are distributing into your parentheses to get rid of the parentheses. So you're using multiplication. So 2 times y is 2y, 2 times 3 is 6, and then it's back to a normal problem. And then once you get x and y, just put them there. You don't have to plug them back in. You guys got this. Let me know if you need help. Let me know if you get stuck.